We're going to be kicking off chapter 10 today and talking about the ellipse shape. So we're going to graph ellipses that are at the origin, write equations in standard form, graph those that are not centered at the origin, and then solve application problems. So there is a lot of mathematics behind many applications that have conic sections. So this is 4 conic sections: the circle, the ellipse, the parabola, and the hyperbola. So all of these have conic sections, and we're going to specifically talk about the ellipse today. If you go on to calculus, you'll see where a lot of this comes into play. So the definition of an ellipse is the set of all points P in a plane, the sum of whose distance is from 2 fixed points, F1 and F2, is constant. These 2 fixed points are called the foci, or focus for plural. The midpoint is the center of the ellipse. So whatever's in between, halfway in between those, is the center. Okay, you can elongate it either direction, horizontally or vertically. The line through the foci intersects the ellipse at 2 points called the vertices. So that's through the foci. The line segment that joins the vertices is the major axis, which you can see is going to be the longer one in both of these pictures. The midpoint of the major axis is the center of the ellipse. The line segment whose endpoints are on the ellipse and that is perpendicular to the major axis is the minor axis. That's the smaller of the 2 axes. So the standard form of an ellipse, its center is at the origin for these. The major and minor axes of lengths 2a and 2b. A and b are positive, and a squared has to be greater than b squared. So we have this one, and we have this one. And we'll see when you use each one. So this first one is horizontal. The major axis is horizontal. So from here to here, you can see that from here to here is a distance of a. From here to here is negative a. So that total distance is 2a. Now the other one, the major axis, or the longer one, is vertical. And you see that is also going to be 2a for a distance because of the endpoints here. So when it's vertical, you're going to use this equation. You can just see that the a squared and the b squared got switched around. Okay, the vertices are on the major axis. A units from the center. So we kind of talked about those already. They're on the longer axis here. Same on this one. The foci are on the major axis, C units from the center. So you can see my ones that are a distance of some amount C. They're on the major axis as well. For both equations, the b squared is going to equal a squared minus c squared. Or you could rewrite it, rearrange as c squared equals a squared minus b squared. So let's start by graphing an ellipse that's centered at the origin. So first we're going to graph and locate the foci on this one. So if you look back to the standard form, we're going to start by finding the vertices. So this one is going to be horizontal. Because the a squared is bigger than b squared, and that's in the denominator of x squared for this one, and the other one's in the denominator of the y squared. So this one indicates it's going to be horizontal. Okay, the vertices are negative a, 0, and a, 0. So the vertices of this one, we're trying to think of what made this number. So that would have had to be a equals 3, because 3 squared equals 9. So our a is negative 3, 0, and 3, 0. Next, we're going to find the endpoints of this minor axis will be vertical, since the major axis was horizontal. So the endpoints of the minor axis are 0, negative b, and 0b. So if we look back at our formula, this is our b squared term. So that means b would have to just be 2. So we'd have 0, negative 2, and 0, 2. Now the foci are located at negative c0 and c0. So a lot of times you're going to get a decimal on this one. So we said we could use this formula, c squared equals a squared minus b squared, to find that. So our a squared term was the 9. Our b squared term was the 4. So c squared equals 9 minus 4, which is 5. So you do the square root, which gives you c is positive or negative 5. So that means one coordinate is, square root of 5. So the negative square root of 5, 0. And positive square root of 5, 0. And then we'll graph those on the next slide. Okay, so our vertices were negative 3, 0, and 3, 0. And that made, again, the major axis. So it's a horizontal ellipse. The minor axis, and it's probably best to plot those first, just to make sure you draw your ellipse nicely. And then our square root of 5 is going to be a little bigger than 2, because the square root of 4 is 2. So it's just going to be, I'm going to do these in black here. It's going to be a little bigger than negative 2 and a little bigger than 2. And that's what my ellipse will look like. Okay, another one this time. We notice it's not in standard form yet, because standard form has to be x squared over a squared, or the b squared could be there. Okay, so our first issue is this 144 right here. To make that a 1, we'd have to divide by 144, but you have to divide everything by 144. So you end up getting this. And then we can do our same step. So this time the denominator of the y squared is greater than the denominator of the x squared. So the major axis is going to be vertical. So this time these are actually going to be switched. This is our a squared. This is our b squared. So the square root of 16 is 4. So we get these for the vertices. And then our other number was, we had to do square root of 9 to get these for the minor axis endpoints. And then we just replaced our a squared and b squared to get c squared equals 7. Take the square root and you get these coordinates to plot for the foci. And then here's a graph. So you can see the vertices. It's a vertical ellipse, like we had said. So this time the major axis goes this way. Okay, so now we're going to kind of work backwards. So this time we know the foci, and we know the vertices. So because the foci are -1, 0, and 1, 0, and those are located on the x-axis, the major axis is going to be horizontal on this one. And the center of the ellipse is going to be in between those, which is going to be at 0, 0. So we can use this form. The distance from the center to either vertex, we had the vertex up here, the vertices. So we have a distance of 2 for each of those. So A is going to equal 2. Okay, so now that we know A is 2, we're going to find the B squared. And we can do that by knowing the C squared. So we know the foci or focus had a distance from the center to 1 and -1. So C is 1. So we know this is going to be 1 squared. A was 2. So then you could rearrange it that way, or you could start here. We know B squared is going to be the A squared minus the 1 squared. So either way you're going to get that, but we'll just do this one because it's already rearranged. So B squared equals 3. So now we can go ahead and fill in our formula. So we would have x squared over a squared plus y squared over b squared equals 1. So if I replace my values, I'd have x squared over 4, because we said a was 2, so a squared is 4, plus y squared over, we just said b squared is 3, equals 1. So that would be our standard form. Okay, then I have another example here you can look at on your own. Okay, now we're going to be looking at just some different ways when it's centered at a different place other than the origin. So at some coordinate HK. So you can read through this graph. It should look a little familiar based on the circle formulas we've learned and transformations. So I'll give you some time to look at that one on your own. Okay, so let's walk through this example step by step. So here's our formula. So you notice that instead of x squared on the top, we have x plus 1 squared on the top. And instead of y squared, we have y minus 2 squared. So this is similar to a circle. The h and the k give us our center. So in order to get a positive 1 here, we would have had to have a -1. And to get a positive, or just some -2 there, we would have had a +2. So here's our center. Okay, if we look, the a squared is bigger than the b squared. So the a squared is the 9 and the b squared is the 4. So the major axis is going to be horizontal and parallel to the x-axis. So that's a good starting point. Okay, so again, we know the center. The endpoints of the major axis are the vertices, and they are 3 units right and 3 units left from the center. And we know that because we had x plus 1 squared over 9. And we said that it was going to be horizontal. So this is the a squared is 9. So just the a is 3. So we have to go from the center and go 3 units right and 3 units left from that coordinate. So you could start and just do it on a graph, or you could add 3 to the x coordinate and -3 from the x coordinate. You're going to end up getting these 2 points. So those are the vertices or the endpoints of the major axis, and it's horizontal. Okay, using that center again, now we can look at the endpoints of the minor axis. So we said under the y squared term we had a 4. So that's our b squared term. So that would mean b equals just 2. So we can go 2 units up and 2 units down. So that changes the y by adding 2 and subtracting 2 to go down. So you end up getting these points. Okay, so now we can go ahead and graph it. So the center is not at the origin, it's at -1, 2. Again, we said that this was going to be horizontal. Okay, and we had to go 3. So a squared equals 9. So the a was just 3. So that's why we're 3 units away. 1, 2, 3 from the center horizontally. And then we have the vertices are at 2, 2 and -4, 2. And then we have the endpoints of the minor axis are those blue points. Because we said that the b squared was right here. So the b was 2. So I went 2 above the center and 2 below the center to get that. We'll end with an application problem. So a semi-elliptical archway over a one-way road has a height of 10 feet and a width of 40 feet. Will a truck that is 12 feet wide and has a height of 9 feet clear the opening of the archway? So here's how we could solve that. We can construct a coordinate system with the x-axis on the ground and the origin is at the center of the archway. So we can see that right here is 0, 0. And the width is 40 feet, so we went 20 this way and then 20 this way. And the height is 10 feet, so that's where they got this coordinate of 0, 10. They went up 10. And we know that the truck is 12 feet wide and has a height of 9 feet. So the truck is 9 tall, and then we would have 6 and 6 here to make a width of 12. Okay, so we're going to go ahead and use this equation. So the equation of the archway, we're going to put 20 squared under the x squared, and then 10 squared under the y squared, and that gives you this formula here. The edge of the 12-foot truck or 12-foot wide truck corresponds to x equals 6, which you saw in the picture. So we find the height of the archway 6 feet from the center by substituting 6 for x and then figuring out what the y would be. So for this x squared, they put a 6 and squared it to get 36. And then you could do many ways to simplify this. They multiplied by 400 to get these to cancel. And then if you did 100 times 400, you get the zeros to cancel. So that's where they got the 4 right there. So they have 36 plus 4 times y squared equals 400 because you had to multiply the other side by 400. Then they subtract the 36 to get 4y squared equals 364. Divide by 4 to get y squared equals 91. If you do the square root of that, you get 9.5 about for y. So a semi-elliptical archway over a one-way road has a height of 10 feet and width of 40. And we're trying to find if the truck that's 12 feet wide and height of 9 feet would clear the opening. So we just found that the height of the archway is about 9.5 feet. and the height of the truck was only 9 feet. So it will clear the opening, but only by half a foot or 6 inches. So barely, but it will make it through.